All right. Before starting the introduction to Neo Protocol session, we are just going to go over about what is Phoenix Guild. I'm sure all of you are present here already know about it because you guys have been in the guild, in the community since the very beginning. So anyway, just give me a minute. Yeah. So what is Phoenix Guild? So we are a community where we help women and non-binary folks get onboarded to Web3, mostly through educational sessions and boot camps. And also we encourage and empower them to come and work on projects or like attempt bounties. And we think that these are some of the ways that is probably easiest and the most efficient way for anyone to get into Web3 or, as a matter of fact, learn about any new subject, right? So that's the route that we are taking as well. Like I said, our mission is to create a diverse and inclusive Web3 ecosystem. We started with our passion to increase diversity in the whole Web3 ecosystem because it was started by the four of us, Krati, Gyan, me, Sri Lakshmi, and Nivedita. We started because we started as a passion project. Actually, we wanted to get more women and non-binary folks into Web3. And then we realized that there is like so much need for it because we still see there's so much scarcity of women in the whole tech and Web3 ecosystem. And now we have Sneha joining us as our core team. So it's just mostly the four of us organizing sessions and like working on the roadmap and seeing what is the best or working towards what's the next best thing for the community. Yeah, also we started off with the Ocean Grant. And what we do, like I mentioned, we do onboarding sessions for women in different various Web3 topics. We bring in opportunities for women in Web3. It could be in the form of bounties, grants, or even projects, or small assignments, or even job opportunities. And yeah, we are encouraging more and more folks from our community, especially women, to go and attempt these opportunities and mentor projects. Our aim is to empower women so much that they go lead the projects, they take up grants, not just work on the tech side of it. And definitely our future aim is to conduct your own boot camps and take sessions. You gain that much knowledge that you can go ahead and do that. Yeah. And who is it for? It is for everyone. The sessions are open to all. We open source all our sessions. It's all on YouTube, but we encourage our mentors and trainings to be, should consist of mostly women and non-binary folks. And so the story so far, we've conducted our educational sessions, very successful Solidity bootcamp, currently ongoing JavaScript bootcamp as well. And these are not up to date, but we've also hosted now multiple events and speaking sessions. And more than $15,000 have been, actually more than $20,000 have been dispersed in the guild in the form of achievements. And yeah, we are all working towards gaining more. I'll stop sharing my screen now and hand over to Divya, who is our Phoenix, who's going to take over and continue the session about Near.
All right.
Yeah. Wait. Let me see. I can stop sharing. Sorry. Yep.
Okay. Oops.
Divya, please give a brief introduction about yourself and then you can go ahead and start.
Oh, yeah. So you can see my screen, right?
Yeah.
Yeah, cool. So, hi, ladies. I'm Divya Preeta. So I have been in TPG since January. Actually, I jumped into this Web3 space a few months back, before which I was working in the academics. So I realized that my knowledge became static and all, then felt the need to work with cutting edge technologies, then pushing myself to achieve something everyday kind of lifestyle. So hence I joined TPG. I was exploring multiple communities like this, and TPG was the one that suited me. It is such a good place for people like me indeed. This TPG is actually facilitating as a bridge, connecting the non-tech folks with Web3 experts, then mentoring us, rewarding us with bounties, and a lot more initiatives they are doing. I'd like to thank Gyan and the Naksh girls for giving me this opportunity again. So moving to the session. Near is actually a decentralized application platform which runs on top of the Near blockchain. So this blockchain, it runs across like hundreds of machines around the world. This is like a permissioned, a performant, and secure enough to create a strong and decentralized data layer of the okay. I got distracted by the chat, sorry. So create a strong and decentralized data layer for the new web. So this NEAR's main mission is to present a platform that is ideal for running applications that have access to a shared and secure pool of money, identity, and data, which is owned by their users. So before we go any further, let's learn some of the backstory and see how blockchain platforms have evolved over time. So ever since Satoshi Nakamoto released the Bitcoin white paper in October 2008, the world has gotten acquainted with this game-changing blockchain technology. And over the last decade, blockchain has gone through nearly 3 stages of evolution. And Bitcoin is the perfect example of the first generation blockchain. The purpose of this blockchain is to be a simple and straightforward payment system. It was originally a hands only. So also there was a major problem when it comes to BTC, like it is quite infeasible to conduct complicated transactions because they had several layers of metadata and logic attached to it. It was not customizable, and then came Ethereum. So this Ethereum, like it was in the second generation blockchain platform. It had smart contracts and all. And finally, developers, they were able to program sophisticated transactions through these smart contracts, and they were able to create decentralized applications. So through these adapts, blockchain's use cases were like bombarding, like it was growing in an enormous amount. However, this space has also been struggling in its own way. Like the main thing is that these blockchains suffer from scalability issues. You know about the number of transactions they can process. Like Bitcoin, it can only do 7 transactions per second. Like Ethereum, it can manage up to 25, but it is quite low when compared to PayPal, which can process 1 on 5 transactions per second, and then Visa, it's quite high, 1,700 transactions per second. So Ethereum and Bitcoin, they have been trying to fix these scalability issues with the layer 2 solutions like Lightning Network, Raiden, Plasma Protocol, etc. So the idea here is to create an additional layer over the underlying blockchain. So in which, like in this through this additional layer, the main protocol, it can delegate repetitive and tedious tasks. However, there were again 2 issues with this approach. Firstly, these layer 2 solutions, they haven't yet achieved acceptance from the masses. And secondly, these layer 2 solutions, they actually kind of ruin the original architecture of the protocol. which may have long-lasting implications. And then thus the third generation came in, Near. So Near, I can say, is an example of a third generation blockchain because it aims to solve the scalability issues, and also it allows both the end users and developers to enjoy the full potential of smart contracts and the blockchain technology. So instead of relying on any layer 2 technology as such, Near breaks us from the idea that every single node that's participating in the network has to run all the code. Yeah, it breaks us from that because it might cause a bottleneck and it kind of slows down all the other approaches. So to fix this issue, Near uses a technique that's already popular in the database world, which is called sharding. So what is sharding? Sometimes you may have to deal with a large bulky data which can hinder your performance and throughput, and it can make the process extremely insufficient. So this is where sharding came in. What sharding does, it makes a horizontal partition of your database and turns it into more small and manageable tables. So these smaller databases, small tables, these are called shards. So how does sharding help blockchain actually? So as we have seen so far, as more and more nodes enter this Ethereum and Bitcoin ecosystem, the entire consensus and the verification process, it's taking even more time. So how sharding is gonna fix this? Yeah, sharding is going to actually break the global state, the world's global state of the blockchain into tinier and more manageable shards. So during shard activation, the global state of the blockchain, it gets split into shards. So each unique account in this chain, I'm sorry, we'll be having an account no in the any blockchain platform, Ethereum or Near. So in each shard there will be separate accounts. So the accounts in that shard will only transact with the other accounts in the same shard. So in order to interact or to refer to details from the other shard, we introduced a concept called receipt. We'll discuss about it in the upcoming sessions, not today. What is the purpose of creating such scalable blockchains like Near? Actually, when it comes to second and third generation blockchains, what it truly determines its innate value is the dApp ecosystem that thrives on top of it. So most of these blockchain platforms are kind of in a competition to attract as many developers as possible by uh, introducing more bounties or hackathons kind of thing. However, the problems with this current platforms is that they don't actually have the ecosystem required to host high quality apps. So basically, we are in a situation where the developers are trying to create PS4 games on a platform that's equivalent to Windows 98. Plus, there is another factor when it comes to like mass adoption, which is speed. Speed is a vital factor when the coming to like application usability, because why would users prefer an application if it is not usable at all? This is why a blockchain platform that is scalable like Near is important for the mainstream adoption of blockchain and smart contracts. So moreover, most web services, they utilize a single server and a single database to process your request and provide information. Basically, it happens in every Web2 products. So this infrastructure is usually managed by an individual entity who treats all of the data processing, like the data processing entirely looks like a black box. So your request goes in, something happens, and you receive the output. So you don't know anything what's happening inside that black box kind of thing. Like we are supposed to trust that what happens between the user and the companies, like it is safe and trustworthy, it's harmless. We are supposed to trust that. um, how Near differs is that Near is also similar in principle to this cloud-based infrastructure, except that this cloud is no longer controlled by a single tech giant, unless this data center is actually made up of all the people, like all the nodes that are running on the Near ecosystem, like these nodes. And so this is the community operated cloud instead of the company operated cloud. In order to set the stage, the Near team, they are actually building a base layer blockchain, or as in a layer 1, which means it is on the same level as the ecosystem that we see, like Ethereum or Cosmos. Basically, so everything in this ecosystem is built on top of the Near blockchain, including your application. It's completely independent. Let's see a quick history about Near. This Near protocol was formed by a former Microsoft employee Alexander and developer Ilya. The team, it kind of grew eventually. So according to Alexander, his goal was to create an internet where all the applications are decentralized and managed by a community where actually no one is spied on. Blockchain is definitely an important component there, but it is not the only component, because they focus more on decentralization, but they also concentrate on the other corresponding values that are necessary. So then following the mainnet launch, the Near team, they began working on some groundwork for mass adoption kind of thing. Like the Rainbow Bridge is actually considered to be the most important one in the Near ecosystem, because this is actually a trustless and permission bridge that enables the transfer of assets between Ethereum, Near, and Aurora. So the Rainbow Bridge, it actually allows developers to use the Ethereum's assets on Near and the Near assets on Ethereum seamlessly without any hassle. So this Rainbow Bridge, it can also be tweaked a bit to connect Near and all the Ethereum compatible chains such as the Binance Smart Chain, Polygon, Avalanche, Optimism, Arbitrum, and much all these Ethereum compatible chains. And then came the Aurora. The development of Aurora EVM is also quite a big milestone in the Near's push for adoption. So Aurora is considered the most important EVM because of its two core components, which are the Aurora engine and the Rainbow Bridge. Aurora engine, it enables the seamless deployment of the Solidity and Viper smart contracts, while the Rainbow Bridge, it enables the permissionless transfer of assets between Ethereum and Aurora. So when compared to Ethereum, Aurora is able to offer the transaction processing fee, or which is like 1,000 times lower than Ethereum, and like it can host like thousands of transactions per second, and it like representing an increase of 50 times over Ethereum. Then in September 2021, Near they launched private shards. Then in November, they created a network token with Travala. Then they created a platform for helping developers create on Near, which is called the Pagoda. Then came the Near Pay, which acted as a debit card bridging fiat and crypto. Then they released their own stable coin, which is quite popular now, which is USN. Let's talk about consensus. The consensus mechanism implemented on Near, it's called Nightshade. Nightshade, it models the system as a single blockchain, like the list of all transactions in each block, it will be split into physical chunks, like, and each chunk will be one chunk from each shard, and all the chunks accumulate to one block. So validators are responsible for maintaining consensus within the protocol. These validators are specialized nodes that need to keep their servers online 100% of the time, while keeping their systems updated continuously. Then talking about the Near token, it is the native asset of the Near ecosystem. This token is a unique digital asset which can be used to pay for transaction, to pay for storing data. Then you can run a validating node validator by using it. Then you can use this token to take part in governance also. Okay. Setting up a Near account. The cool thing about Near is that it offers you readable account IDs like Twitter in a very cheap price. So account IDs kind of work like website domains. Like they also have subdomains. Like I created this divyapreeta.near. This account can have a sub account like tpg.divyapreeta.near, and this account can also have a sub account like project.tpg.divyapreeta.near. So each of these sub accounts has its public key, unique public key. So one account, like main account, it can have multiple public keys representing various profiles. These public keys, they are also called access keys. The purpose of these keys is to grant permission to act on behalf of the account. Currently, we have two types of permission. One is the full permission, and the next one is the function called limited permission. So full permission, it allows the key owners to fully interact with the Near platform, like deploying code, signing a transaction, then sending a transaction, like all functions, everything. Complete control is given to that key owner. Next comes the function call permission. So this allows only limited permission for other accounts to call methods of a script restrictive when you don't trust the thing. Keep in mind that when you give full permission to any user, make sure that you know the platform quite well. So because they have full access, or else you have to revoke the permission later. We'll talk about it in a few minutes. So you can create your testnet account by visiting like wallet.testnet.near. Then you can choose your nickname. If the nickname is available, then you can join. Okay, then you'll choose a security method. Okay, after selecting, your testnet account is ready. So initially, Near, your testnet account is credited with 200 Near tokens for anyone who joins the Near testnet. Talking about Near Explorer, since the Near blockchain is public, anyone can query it to get any data stored in it. Near Explorer, it allows you to view block creations in real time. So this useful tool, it allows you to search for transactions and accounts, allowing you to view all interactions between the users and smart contracts. So applications on Near, they have two distinct parts common, like backend and a front end. A backend is the smart contract where you can store and modify your data on this chain. And the front end is the user interface where you can interact with your contracts, the contracts you have deployed, or the contracts deployed by other people. So obviously you need a testnet account to build on Near. Also, creating an account on mainnet is also identical to testnet, but you will need an initial funding for that account. But maybe my testnet account ID is like divyapreeta.testnet, because that is free of charge. But my mainnet account, in my mainnet account, when I want to get a customized name, I should pay like around 0.50 Near tokens, or else it will give a long public address, just like how your ETH address will be. a slight change. If you have Near tokens, you will get your customized name, which will be quite cool in a like to share, is easy to track and all. So once your account and all is ready, you can use the Near CLI, which is the command line interface, which allows you to interact with Near. So after installing, you can try your first command like Near space login. We'll not be dealing with today, probably in our next Near series. Today it's just about introducing you to the Near ecosystem, like what are things going on. Then speaking about the Near environment, it is divided into 3 layers. First, what you see is the app layer. Basically, this includes the services and the user interface that you interact with. What you see, the front end and back end, it will include all the high-level libraries that are needed to interact with the Near. So these components, it enable communication with the Near ecosystem in order to execute this code. So communication between the app layer and the protocol layer is channeled through an RPC interface in Near. Then comes the protocol layer. This is the place where your transactions or your storage request gets validated via the Near consensus mechanism, and it gets added to your public ledger. This is done by the validator nodes, as I mentioned. They do their job in this layer. So Near, it actually sits between the app layer and the runtime layer, and communicates with both other layers. Finally, we have the runtime layer. This runtime layer, it can be considered at the same level as the protocol layer, what we say. This runtime layer is referred to this layer 1 is the resource layer, because the real computations that happen here usually. So once the validator node validates a transaction, the actual reading or writing, like updating the state storage on the blockchain, it happens here actually. Then speaking about the Near virtual machine, it is the Near VM is a modified WebAssembly virtual machine to execute WebAssembly bytecode instructions. So in whatever languages you write, your contract code, it should be compiled to WebAssembly bytecode in order to be able to deploy it on Near VM. Then speaking about Near transaction processing, so the validator nodes, they run the VM and execute the operation. So they take incoming transactions, validate it if they meet the requirements to be executed. So if an account, it wants to call a function in a contract, it will send a request. The validator will check if the contract and the function it exists, then if that function it can be called, whether it is public, it is accessible for whether the public can call it, or is it restricted function. It will check all those things, and then it will again check if the account owner has properly signed the transaction. So if all these 3 requirements are met, it will spin up VM and then execute the function, and the results will be returned. So after the computation occurs, the VM, it'll quit. Speaking about transaction gas, so each transaction takes some bandwidth to be included in the ledger. Hence, here in Near, we'll be paying some cost in gas, like in Near, to the validator nodes. So interacting with the Near CLI, we'll speak about it in our next session. And speaking of Near contracts, as I mentioned earlier, contracts, they are used to read or alter the state of the Near network. The contracts, they are executed on the Near VM. That's obvious. So the contract code, it gets compiled to WebAssembly bytecode. Then it will be deployed to the Near blockchain. So if once I have deployed my code, it means it gets uploaded and it gets stored in the Near blockchain. So so anyone connected to the network, they can see and interact with my contract. So if a user provides a valid input, and the contract will provide its expected output. So basically, these are these actions that can be performed within a transaction. So commonly these things can be considered as a transaction, like creating an account, deleting an account, then adding key, like the key can be either a full access key or a function call access key. Then you can delete an existing key. Then also you can transfer funds from one account to another. Then you can take part as a validator node by staking some coins that also count as a transaction. Then you can deploy a contract, or we can make a function call. So okay, then so imagine that you have written your first smart contract on Near, a simple hello world or whatever. Now it's time for you to deploy your contract. So only when you deploy your contract, you can interact with it, or I can interact with it, whoever. So deploying a contract, it actually follows these 4 steps. First, your smart contract, the code, it will be compiled to WebAssembly bytecode. Then a transaction will be created, just now how I mentioned this. This transaction is the deploy contract transaction. So it will contain all the necessary values for Near to deploy a smart contract. So this transaction, it will alter the VM state. So after that, so anyone can create a transaction, but only a transaction is considered valid only if it has the correct keys and the user has signed it properly. So if you have signed your transaction properly, it will then get broadcasted to the Near, and the validators, they'll start validating your node, and eventually the code will get deployed to the network. So also, if we have a if you have given full access to the platform you are interacting with, you have the access to redeploy it. Also, you can revoke your access if in case you don't trust it. You have all those things in your wallet. You can update those things. So imagine your contract is deployed. It is now it is stored on the Near blockchain. So if any user, like if I want to interact with your transaction, interact with your smart contract, what I do is only way to interact with the smart contract is by calling their methods or functions or methods, what we call. So commonly what happens when I interact with a dApp is that, so for this, the name of the transaction is the function call transaction. You remember it, right? So when I do a function call transaction, what will happen behind the scene is that your dApp, it will use the Near API JS to compose and sign the transaction that represents a function called transaction. Then this transaction is sent to the Near platform through the RPC interface. This interface, it will validate and verify the transaction before routing it to the correct shard based on the contract account. So in Near, the thing is that each smart contract will have its own contract account. So this is okay, you'll get used to it eventually. Then okay, once the Near RPC interface will validate your transaction to the correct shard, then the runtime layer, it will wake up WebAssembly virtual machine. Then the VM, it will load your contract code, then invoke the function that you called from that which was mentioned in the transaction. Then the reading or writing, whatever, storing to the state storage or whatever that happens. Then the results of the function call, it will be returned, and the VM will be spent down, like it will be quit. Now the blockchain layer, it will be routing the result back through the RPC interface to my dApp. Like I can see it on my user interface. Yeah, this is what happens usually. Then where to start? So that's it. these are some good places to start exploring near. First, do the near.academy, what is mentioned in near.academy. It's a very short kind of thing. And in learn near.club, you can find quite a lot of resources. So let me check whether my mentor, he said he'll join. Let me check whether he's here. Yeah, so he didn't join, maybe he's busy. So that's it. If you have any doubt, you can ask. Okay, let me check the chat.
So for those of you who have joined this session and you want your own near name, feel free to just ping me. I think Skandesh has already pinged. Skandesh, can you also share your email ID so I can gift you a near name? It's just a fun thing and it's like a fun way for you to sort of,
Yeah,
you
to
know,
sharing it with others, kind of cool, like AI to have a domain name.
yeah, I'm gonna give you, wait, I'm trying to create one for Skandesh. If anybody else wants, like, I am happy to gift you a near name.
That's so sweet of you. I will ping you the email ID again. And
Right.
I
So
have a couple of questions to Divya regarding this session. I don't know if you mentioned whether what consensus they use. Do they use proof of stake or any something like that?
yeah, it's proof of stake.
Okay, okay. And also another thing was, you showed something like ASSTK. So I assume that is assembly script. Is that something a
Assembly
separate
script.
language
Yeah,
or?
it's assembly script. Previously, only Rust and assembly script was included. Now, as Gyan announced, the JavaScript SDK is also included.
So what is it assembly script? Is it a separate framework or a
Uh,
language?
yeah, I'm not such a technical person. Maybe Gyan will.
Yeah, so assembly script is similar to JavaScript, and basically it helps you write contracts. So it's little bit, it's not that like memory safe and all like Rust, but it's just a good like easier one to get started. So the language is I would say little bit at the intersection of TypeScript and JavaScript, but yeah, it's very straightforward.
Okay, awesome. And last question. Divya mentioned like the contract account would be contract would be stored in a separate account. So
Yeah,
that
so
account is something.
under my thing, like in divyapreeta.near, if I'm deploying like 2 or 3 contracts, so each contract will have a like a sub account name, like the so that it'll be easy to track the funds and all. So each smart contract will have a unique account name. That's why they are giving subdomains. Was that your question or did I interrupt?
Uh, I got confused more because the
Okay,
subdomains will be
now
created by the
so
one who deploy the contract, or is it a whole separate account?
So let me, okay, I'll just add to that. So basically, what happens is like, this is more of like when you get more into near, this information is important to understand. But just to give you parallels, like how in Solidity, right? We store, you have different types of accounts, right? You have externally owned accounts and you have your contract accounts. Okay. Like if you are not familiar with Solidity, this is how it works. There are externally owned accounts, and the moment you deploy a contract account gets created for that particular contract. But in near, what happens is whenever you are deploying a contract, you have to deploy a contract to an already created account. A new account doesn't get created for the contract. Okay. So what that means is, suppose you have skandesh.near, your account can hold a contract that you have deployed in your account. So the storage of that contract is associated with your account, and your account, every account can hold only one contract. So this is the slight difference between how like EVM works versus how near works.
Got it.
Is
Yeah,
that
got
clear?
it.
yeah,
Do you?
So
okay.
if
So
I
I
want want
like to add a point to that. That was a very clear explanation by Gyan. So I'm into this creating a DAO in the Near ecosystem. This is what I saw yesterday. The Sputnik, there is the platform Sputnik DAO. It is a place where you can create your own DAO on Near. So this when I create a new DAO, so there is a parent account ID which is Sputnik.DAO. So they have this custom user interface kind of thing. So I don't have to do any code. I can create a DAO using my interface. So whatever DAOs are created, like if my DAO is the Ava DAO, so I'm building it on the Sputnik.DAO. So sorry, Sputnik.near. Sorry, I confused it. So my thing will be ava.sputnik.near. Then if Gyan is creating Gyan's DAO's contract address will be gyan.sputnik.near. So is it relatable or did I confuse?
Yeah, I understood. But it gives me a whole new question where if I want to interact one contract with other, uh, be- because Solidity allows us to do that through interfaces. Now it seems that the contract is linked to an account where it links to the private key of that holder. So every time when we want to interact two accounts, contracts, does that every time the user has to sign, or how does
No,
that
so
work?
Yeah.
no. So basically, you can have cross contract calls in Near as well, and it doesn't. It's not required to have the private key of the other contract, because the way contract is stored in like memory, it is different than the way. So basically, see your contract, right? The functions that you write in the contract, if they are public functions, then other people can call those functions. So those rules of code still apply. Just the storage of that contract is in a different place. Like, it is not abstracted within an account. So like an account does not hide the contract. Okay. The account just holds the contract. So in this case, where you're saying a private key is required, your mental model is more like, okay, this account is hiding the contract. So I need to have access to that account to have access to the code. That's not true. This account is just holding the code with that. And then you, whatever elements of that code are public, you can still access. If it is private, then you still can't make a smart contract call, right? So all those rules of access will work the same way.
Got yeah. So the data is linked with the account, but it is just the fundamental change with within the EVM and the Near. So I got it. Thanks.
Yeah. So this is just a little fundamental like mental model change. When you think of where contracts are actually residing, there is more technical explanation to this, like in terms of why they chose the storage this way and stuff. But I think it might become heavy for now, and maybe it's good for like solitary reading. So then we can also have more deeper discussions on that. Are there any other questions? No? Okay. Skandesh and Pramoda have shared your Near names to you. Please use the link that I shared to claim your Near names. Those are like unique links for each of you. If anybody else wants a Near name as well, feel free to drop me your like first name or something, and then I can give you this. I can create one and give you. And this is also giving you like 0.5 Near for free. So enjoy.
So yeah,
That's
Gyan,
so
thanks.
generous of you, Gyan.
It's not that much,
Yeah. So I
Hey,
just want
All right, guys. Gian, Joanne wants the new name, so you can DM her and Priya as well. And
yeah, I have Priya. Priya also has given one, but Priya, the name you have given is like little like